In problem 92, we're taking a look at I to the nth power. There's been several homework problems now where we've been dealing with I to some exponent. There was one in the last couple lessons, but the previous two problems before this were actually really important for this idea as well. So to really understand this, I'm going to go back and actually look at problem 90. So in problem 90, first of all, it says on problem A that we know this information. Well, anything to the 0 power equals 1, so that one works out. I to the first equals I, that makes sense. And I squared is -1. And when we first started dealing with this in imaginary numbers, that was one of the first things that we learned, is that I squared is -1. A previous homework problem had I to the third, and then it had you try to guess what you thought I to the fourth would be. So I to the third is the same thing as I squared times I to the first. This is -1, so I have -1 times I to the first, which is just then -I. So that means that I to the fourth is going to end up equaling I squared times I squared. And I'm going to show this two different ways. That'd also be -1 times a -1, because each one of these is a -1. And -1 times -1 is +1. A secondary way that I could write that, I squared times I squared, would be I squared quantity squared, because it's the same thing. So I can square it. Well, that's -1 squared, which is then, again, 1. So let's take a look at this pattern. If we just look at these first 8, so we already said from before that one is just I. This was -1. This, as I had just gone over, is -I. And this is +1. This one right here is crucial, because now what I can do when I talk about I to the fifth, I could say that I to the fifth is I to the fourth times I. While I to the fourth is 1, so this is 1 times I, or just I. So actually I to the fifth is the same thing here. Well, very similarly, I could write I to the sixth as I to the fourth times I squared. I to the fourth is 1, and I squared is -1. So this equals a -1. I to the seventh is I to the third. I to the fourth times I to the third. That is a 1, so I just have I to the third, which is -I. I to the eighth is I to the fourth squared, which is 1 squared, which is 1. So again, it's back to that. If we continue that process, let's say I say I to the 9th, I to the 10th, I to the 11th, and I to the 12th. Well, I to the 9th is actually I to the 8th, which is I to the 4th squared times I, which is now right back in line with just I, because all of this is just 1. I to the 10th, I to the 4th squared is I to the 8th times I squared. So I to the 10th is the same thing as I squared. I to the 11th, if you're picking up the pattern, is going to be I to the 4th squared times I to the 3rd, which is going to be the same thing as just I to the 3rd, which is -I. I to the 12th, if you haven't already guessed it, is I to the 4th cubed, which is just 1 cubed, which is 1. So as you can see, this pattern just keeps going and going and going. So when we look at the next, we're supposed to go all the way to I to the 15th. So if we did that, I would have I to the 13th, I to the 14th, and I to the 15th. I to the 13th is going to be the same thing as I. I to the 14th is -1. And I to the 15th is -I. So now we're looking at this pattern and trying to make sense of all this. I to the 16th, well, that one should just be 1. But if we start looking at like I to the 25th, so how many times can I get an I to the 4th out of that? So I to the 4th to the 6th power is the same thing as I to the 24th. So if I'm looking at I to the 25th, that can be rewritten as I to the 4th to the 6th, which is just 1. That's I to the 24th times I to the 1st. Since this all is 1, I can just get rid of all that, and it just becomes I. I to the 39th. How many I to the 4ths do I have in I to the 39th? Well, I to the 4th times to the 9th is I to the 36th. It is still equal to 1, because it's still I to the 4th. So I to the 39th is I to the 36th times I to the 3rd. This becomes a 1. So I just get I to the 3rd, and I to the 3rd was a -I. So hopefully that'll help you figure out what C, D, and E would be. And now I'm going to go back and look at this. Describe how you evaluate I to the nth, where n could be any integer. Well, if n is a multiple of 4, so it's 4n, that means it's going to equal the same thing as I to the 4th, or I to the 8th, or even I to the 0. It's going to equal 1. Or if you have an integer, that would be 4n plus 1. So that would be the same thing as I to the 5th, I to the 9th, I to the 13th, and so on. That is going to be the same thing as 1 times I, which is just I. If you have 4n plus 2, this is your just 1. I squared is going to end up being -1. 4n plus 3, this is just your 1, and plus 3 is going to end up being a -I. So it doesn't matter what integer you're looking at, you figure out how many times you can divide it by 4, and what is the remainder. In case you're wondering why I stopped here, the next option would be after that one would be 4n plus 4, which is the same as a multiple of 4. So this equals 1. Hope that helps.